Hi everyone, my name is Amitesh, and in this video we're going to master this very difficult limit here. And I say it's very difficult because if you can master this, then you can master any limit in my opinion. So we're going to dive into this, and I'll mention that this was a very difficult problem in an assignment before an exam at Princeton when I was teaching freshman calculus one semester. It was considered one of the hardest problems, and it really matters whether x goes to negative infinity or x goes to infinity. The answer is completely different. So watch till the end. If you think the answer is the same when x goes to plus minus infinity, watch till the end to see how much this matters, okay? So let's just dive into it, and we'll go through all kinds of limit tricks. So the first step before we sort of understand a limit is diagnose it, okay? So what is it really? What's going on? What are the terms going to? What kind of indeterminate form it is? So basically here, if we think about as x goes to negative infinity, the x squared plus 5x, well, the x squared term is going to dominate, okay? So this is important. As x goes to negative infinity, x squared is going to become larger much faster than the 5x becomes small. In the sense of if x is 10, then it's going to be, x is negative 10, it's going to be 100 minus 50, which is 50. But if x becomes negative 1,000, it's going to be 1,000,000 minus 5,000, which is a much, much larger number, 995,000. Okay, so basically the x squared term is kind of dominating, and so the root of this expression is still going to go to plus infinity as x goes to negative infinity. Okay, so x squared is going to go positive much faster than the 5x is going to be negative, even though x is approaching negative infinity. The second thing is the same thing is true for this side, okay? It's the same principle. This expression here is also going to positive infinity as x goes to negative infinity. So it's also important to point out that, this may be undefined if x is really small. You may be taking the root of a negative number, but as x goes to negative infinity, x squared plus 5x ends up going to infinity. So in particular, it's positive and you can take the square root. Okay, so this is the expression. It is what is called an infinity minus infinity indeterminate form. Now what this means is that what's going to matter, and this is so cool, right? That this actually turns out to be a number that doesn't even look like any of the numbers that are in the picture right now. It turns out that the rate at which this is going to infinity and the rate at which this is going to infinity are all basically the same, and they just end up differing by a small constant as x goes to infinity. So we are going to figure out what that constant is. So how are we going to do that? So the first step, when I see something like square root minus square root, is I want to get rid of the square roots. Square roots look messy. We want to try to get rid of them, and we want to try to do that by multiplying something on the top and bottom. This is also important because generally infinity minus infinity limits look bad, but we understand how to deal with infinity over infinity limits, for example. Okay, we can sort of manipulate it into a fraction, and we sort of have more experience with those. So let's multiply top and bottom by what is called the conjugate. And before I do that, I'm just going to give you a quick reminder, is the difference of squares formula, that if you have something like a minus b and you multiply by a plus b, it's going to be a squared minus b squared. So this is going to allow us, if the a and b involve square roots, it's going to end up squaring them if we multiply by a plus b. But of course, anything we do, we can't just multiply by something, right? We have to multiply top and bottom by the something. So then the top and bottom cancel out, and we were basically where we started off with. So that's what we're going to do. We're going to multiply top and bottom by what is called the conjugate, which is change this negative sign to a plus sign. So we get like an a minus b times a plus b formula. So here we're going to just do that. I'm going to do that in two steps. X squared plus 5x minus square root of x squared plus 2x times square root of x squared plus 5x plus square root of x squared plus 2x. Okay, so I've just changed the minus sign to a plus sign and multiplied the bottom also with that. Okay, so we need to divide by what we multiplied by. So now we're going to get x squared plus 5x plus square root of x squared plus 2x. Okay, so that's step one. Now we're going to get rid of the square roots on the top, and that's going to help us out. So what happens to the top? Let's use the difference of squares formula. We can simply say that a and b are going to be these two expressions, right? This is a and this is b, right? In our formula over there. And so we get a minus b times a plus b. And so now all we have to do is just say that's a squared minus b squared. So let's dive into that. We're going to get a squared minus b squared. So limit x goes to infinity of, we're going to have x squared plus 5x, which is a squared, minus b squared, which is x squared plus 2x, divided by what we had on the bottom, which we're going to have to deal with. Okay, we've moved the square root to the bottom, But the main point of multiplying top and bottom is now we're going to get an indeterminate form that's something like infinity over infinity rather than infinity minus infinity. Okay, so that's the strategy there. So let's kind of work out what happens next. Okay, so we're at this point, so we can simplify the top now. Okay, and this is kind of going to highlight the dominant term stuff. Okay, so the x squared is what is governing kind of this going to infinity and this going to infinity. It's the fastest thing that goes to infinity. So what's going to happen is it's going to cancel off now on the top. Okay, so let's see that. So we're going to say that when we simplify this, x squared plus 5x minus x squared plus 2x is just going to equal to 3x, right? The x squareds are going to cancel off. So I'm just going to do that here. X squared cancel off. Don't forget to distribute the minus sign in the brackets. That trips people up sometimes, trips me up sometimes. So it's going to be 5x minus 2x. So we're going to get limit x goes to negative infinity of 3x divided by the square root, which is square root of x squared plus 5x plus the square root of x squared plus 2x. Okay, so that's going to be the expression. So now what's going on, right? So in some sense, we've simplified the problem, but it may not look like that from a first glance because you still have the square root and it's still an infinity over infinity kind of limit. As x goes to negative infinity, 3x is going to negative infinity. Negative 3 times infinity is still going to negative infinity. And the bottom is also going to infinity plus infinity now. So it's no longer an infinity minus infinity thing. It's infinity plus infinity, which is definitely infinity. Okay, so two big numbers adding up, they're going to still be big. So we're going to get what is an negative infinity over infinity indeterminate form. But we have methods for dealing with that. And this is where, I've done another video. If it's uploaded, you can check it out. It's important to grasp, to that too. But we'll see the idea here, which is the idea of a dominant term. So just like 0 over 0 limits have a culprit, something on the top is 0, something on the bottom is 0, and you often try to cancel something from top and bottom and then plug in for a 0 over 0 limit. Infinity over infinity limits or negative infinity over infinity limits also have a culprit in the sense that you can cancel something off from top and bottom that is pushing the thing to infinity or negative infinity. So on the top we have the x, right? So that's what's pushing it. On the bottom, we don't have an x, but we're going to try to factor out an x on the bottom. Okay, that's going to be the strategy. So we're going to factor out an x on the bottom. How are we going to do that? So the way we're going to do that is we're going to factor out an x squared from each square root, and the square root of x squared is going to end up being something like x, and the something like x is going to become clear soon what I mean by that, and then we can cancel off x from top and bottom. Okay, so we're going to factor something off from here, so I'm just going to do it on this side of the board now that we've kind of written it down there. So we are going to take the square root expression and we're just going to factor out an x squared from each of the square roots, and then once you take a square root, you're going to get rid of it, or get rid of the square. So what we're going to do here is we're going to, I'm just going to write this out. We're going to have square root of x squared plus 5x plus square root of x squared plus 2x. So we want to try to cancel off an x from top and bottom. So we're going to factor an x here. Let's factor an x squared inside the square root. So we're going to get x squared times 1 plus 5 over x plus square root of x squared times 1 plus 2 over x. Okay, so you're literally dividing x squared plus 5x by x squared and multiplying by x squared. So the x squared comes out and you divide x squared plus 5x by x squared, which is going to be 1 plus 5 over x. Because 5x over x squared is 5 over x. Same idea here, get x squared times 1 plus 2 over x. And now you're just going to factor out, it's going to be square root of x squared times square root of 1 plus 5 over x plus square root of x squared times square root of 1 plus 2 over x, which is now going to equal to the square root of x squared times the square root of 1 plus 5 over x plus the square root of 1 plus 2 over x. Now, you may wonder why I haven't made the square root of x squared just x. And this is the fundamental thing. This tripped up a lot of people. So as I said, when it was a problem before an exam at Princeton, it definitely tripped up. It was a question that came up a lot, is the x goes to minus infinity is really going to matter here. And I've done a video on this on my channel. Please check it out. It's the square root is not the inverse of a square. To really master absolute values, square roots, when they come up a lot in pre-calculus and calculus, the square root of a square is not x if x is negative. Think about x is negative 5. Take the square of that. It's 25. Take the square root of 25. It's 5. So we got back not negative 5, but 5. Okay, so the point is that when you take the square root of a number, you're always choosing the positive value. Okay, and I've explained this all in that video, so I encourage you to check it out. But what we're really going to get, we're not going to get x back, we're going to get the absolute value of x. Or in this case, because x is going to negative infinity, it's going to be equal to negative x. Okay, so I'm just going to write it out that way. It's going to be negative x times the square root of 1 plus 5 over x plus the square root of 1 plus 2 over x. Okay, that's what we're going to get. And now we can sort of write that out here, and we're going to cancel the culprit. The reason it's infinity over infinity on top and bottom, we're going to cancel that culprit off. So we're going to get x goes to negative infinity of 3x over negative x times the square root of 1 plus 5 over x plus the square root of 1 plus 2 over x. And now, once you've taken out, this is a cool thing, the x squared is why this thing was going to infinity. So once you've taken out the x squared from the 1 plus, and you got 1 plus 5 over x, what happens is x goes to negative infinity, right? So first thing is let's cancel off the x's. So we can get a negative 3. Okay, the negative sign is important. If x was going to plus infinity, there would be a positive sign there. Okay, so it's going to be negative 3 times the limit as x goes to negative infinity of 1 over the square root of 1 plus 5 over x plus the square root of 1 plus 2 over x. Okay? So that's going to be the answer. But now, what is happening? We can now plug in. As x goes to negative infinity, doesn't matter x goes to infinity or negative infinity, 5 over x is going to 0 because you're dividing by a big number. So you're going to get 1, this is going to 1 here. And this expression is also going to 1 here. So we're going to get 1 plus 1 on the bottom. Square root 1 is 1. So square root 1 plus square root 1 is 1 plus 1, which is 2. You get 2 on the bottom. It's a negative 3 on the top, so it's going to be negative 3 halves. And that's going to be the value of the limit. And I find it really beautiful because the original limit, you had a 5 and a 2, and you got a negative 3 halves, right? So somehow that looks nothing like the 5 and the 2. Yes, the 3 comes from the difference between 5 and 2. But which difference? Why isn't it plus 3? And that's why I said the x goes to negative infinity is important. So this is what we would call a horizontal asymptote at infinity, or negative infinity, sorry. So the graph, the y value will approach negative 3 halves. So it'll approach the line y equals negative 3 over 2, which is a horizontal line parallel to the x-axis, where y is a constant value as x goes to negative infinity. So thank you so much for watching. I hope you loved that video, and it's a really hard limit. If you master this, you understand the idea of multiplying by the conjugate, you understand dominant terms. So I encourage, play around with the numbers, change some of the numbers up, go through the process. That will really help you master it. And please like and subscribe, share with your friends and family. My goal is to create infinite, free, accessible math education, a library of math for everyone to love and benefit from it. Elite math education to you in your room. It doesn't matter which high school or college you're attending, so you master math and you love math. And even if you don't love math, but you master it so you can do well on your exams, I'm still here to support you. So thank you so much. I wish you all the best wherever you are, and I'm super excited to see you in the next video. Please take care.